Ladies and gents, our next step in our journey through the solar system takes us to the two planets we know the most about, Earth and Mars. Let's take a look through some of the things you're very familiar with. Others may surprise you a little bit. The parts of the Earth we don't know that much about, how it formed, the parts of Mars that we just starting to learn a little bit about what it used to be like after it formed and how it got to be the way it is today. Let's take our journey together. Here we go, Earth and Mars. All right, in these animations, you can see them rotating serenely. Notice both of them rotate the same direction, to the east. So for both planets, the sun rises in the east and sets in the west. Also, the length of their day is very similar. With Earth, obviously, 24 hours. On Mars, 24 hours and about a half an hour extra. So 24 and a half hours long. Very similar to the way it is on Earth. Gravity on the two planets will be very different, though, because Mars is much smaller than the Earth. Earth, we have 1g, one force of gravity. On Mars, however, it would be about a third of the gravity you would feel all the time. It's just less mass, a weaker force of gravity than we're used to, so you could run and jump much further on Mars. You could leap up in the air and have time to think about it before you came back down again on Mars. Interesting future awaits the people who go there. All right, let's talk about our planets and what we know. Starting with the one we know the most about, taking a look at the Earth. Okay, quick reminder as we look at these two, chapter 1A, the first half, is due on the 17th of September. Make that your goal. That's your finish line, page 17. Okay, our beloved Earth, beautiful blue marble in space. The astronauts who go to the moon and come back say that they've never seen anything so beautiful. It brings tears to their eyes as they look at the Earth from a distance. Gives them a whole new perspective. Now, how did it start? Earth had a very interesting, violent past. It started off with impacts and rocks conglomerating together through their mutual gravity, and eventually it accumulated so much of these rocks in the early solar system that it started to form itself into a sphere. That's what gravity does. You get enough material, it starts forming a sphere as all mass is drawn toward the center of that mass. And spheres are like nature's natural expression of gravity. So the accretion of these rocks in space started making the young Earth grow even bigger. And then it became so massive, so big, that any rocks nearby were just pulled straight down from wherever they were orbiting nearby. And they added mass and added force of gravity to the very young Earth. Every impact during that era of bombardment added heat energy, impact heat energy, to make the young Earth even warmer and hotter. And to this day, the heat of that formation is part of what keeps the core of our planet at 10,000 degrees. It's still toasty warm down there, and it is never going to cool off completely. How we got our moon is an interesting part of the Earth's formation. The original theories suggested the moon formed next to the Earth around the same time period, and that they were made of the same stuff. Well, what they found later when they brought back samples from the moon was that it's not the same combination of materials as the Earth is made of. It's different enough that it formed separately from the Earth, and they think maybe came from somewhere else. In fact, the leading theory is the giant impact theory, that an object the size of Mars wandered too close to the Earth, crashed into the Earth, and Theia was utterly destroyed. The Earth was rippled and rung like a bell. The surface would have shown huge waves going across the entire planet. Most of Theia's mass was added to the young Earth, and all the shattered remnants of Theia would have orbited around the young Earth, and briefly, like Saturn, the Earth had a ring of debris around it. And gravity, continuing to do its thing, pulled all the debris in that ring around the Earth, and eventually it formed a moon, very close to the surface of the Earth at first. And then tidal forces over billions of years have pushed the moon away, and it's still drifting it away at about an inch and a half every year. The moon drifts further from the Earth. All right, I'm going to show you a video now. There's no sound on the video, but I'm going to kind of just share with you what we just discussed, and you'll see it visually. The formation, accretion, the era of bombardment, the giant impact, and the young Earth taking the shape that would eventually become what we know it as today. So the young solar system would have been a place where in the center was a dense hot mass of gases where the sun had not formed yet, but eventually that sun was compacted, that those gases were compacted so much it would have started fusion and we would have sunlight from our star. The rocks that were forming a little further away would have accumulated together with their mutual gravity and made that mass that would eventually be the Earth may grow bigger and more massive, stronger gravity, and eventually it took on the shape of a sphere. The bombardment continued. The heat of every impact was delivered to the young Earth. The surface would have been molten. There would have been gases escaping from under the surface, so it would have had a rudimentary atmosphere. But every impact delivered more heat. Vaporization of impact sites would have created a toxic, fumed atmosphere, thin, wispy, certainly incapable of supporting life, and the whole surface would have been a violent, hellish place. As the outer layer started to cool off, small pockets of solid land would begin to form in what is otherwise a molten liquid surface. And then something big happened. Theia arrived. Gravity pulling anything nearby. The Mars-sized Theia would have wandered too close to the Earth, menacing, inevitable, unstoppable. Watch as the Earth, the gravity, bulges the Earth up towards Theia to meet it, and then the two collide. The Earth is ringing like a bell, vibrating, shockwaves sent through the planet, across the surface. The debris of Theia kicked up into the air violently, pieces of it splashing back down, kicking up even more debris. And eventually that debris settles into a ring around the Earth. For a brief time, the Earth resembled Saturn. The pieces of the debris in that field would have conglomerated together to form the moon, and at first it was very close to the planet's surface. It would have filled up half of the night sky if we'd been able to somehow stand on the surface and look up at the moon. It would have been huge. Over time, the moon drifted away. The bombardments from space, the meteors and asteroids that happened to be nearby, meteorites impacting the surface, a violent era. In fact, there's even a suggestion that somewhere in the midst of this violent epoch, one or more of these impact objects would have carried inside its core a mixture of chemicals, organic compounds that might eventually form life. Small crystals of carbon, hydrogen, oxygen, nitrogen. The foundations of what would eventually be life on Earth may have been deposited by one of these impact events. Over time, the Earth's surface would cool, the crust would thicken and grow solid. Vapors would gather in clouds and start raining down on the surface, fill in the oceans. You get the idea. And over a long time period, Earth would have settled down to something much more of what we know today. Early on, the young Earth would have had those shallow seas and eventually much deeper oceans. But those organic compounds would have formed the first foundations of life. I'm talking bacteria, very primitive uh, forms of almost like life, but it could replicate itself. And they started producing as a toxic waste product. To them, it was toxic, but it gave our atmosphere all the oxygen it has, those stromatolite beds. And there's still a few places on the earth, here in Australia actually, where um, where these stromatolites colonies still live, like you see on the picture on the left. Over time, evolution, variations in DNA started taking on its many different expressions to form grasses and trees, bushes, and a rich, abundant growth on the land. Life in the oceans eventually learned to crawl out onto the land and be successful. We have all these ages of the earth: the Hadean age, the oldest, Archean, Proterozoic, Permian, Triassic, Jurassic, Cretaceous. Now we're talking about dinosaur eras. And nestled in all that time, 5 devastating extinction level events that we'll talk about some more later on in the course. So the earth went through lots of changes until we reach now. Okay? And the time that we have now is known as the Anthropocene. Because humans are making so much change to the earth, scientists are in agreement. We're now creating a new period of time for the earth because it has changed so much because of human presence, our activities, the waste products of our civilization. This slide is not meant to depress you, but to make you aware that even in the midst of devastating things humans have done, we're starting to fix the things that we were at first oblivious to, and now we're starting to make them. As we get a better perspective on the earth, we start realizing our awesome responsibility to take good care of the earth, so we have a beautiful planet to pass on to our future generations. That's where we're at. Little background of the earth, how it formed, where our moon came from, where the earth is now, and our great responsibility to care for it. Let's take a look at the other planet that we know extremely well, and we're headed there next. I give you Mars. Mars has volcanoes bigger than any other in the solar system. Mars has a valley that makes the Grand Canyon look like a little scratch on the ground. We're going to explore some of those things, some of those features on the red planet today. Check it out. First, Mars was beautiful and idyllic. It had lakes the size of seas. It had rivers flowing across the surface. It would have had canyons and waterfalls. It would have had an atmosphere rich with clouds and falling rain. But was there life mixed in? We just don't know for sure because we haven't found proof, no evidence of life being on Mars, even though it had, in theory, all the essential elements. It had all the minerals, it had the water, it had a good temperature, a decent atmosphere, but something went wrong before Mars could really get started in supporting life. That core of Mars, being smaller than the Earth as it is, the core cooled off too quickly. And when you don't have a spinning molten core, your planet loses its shield against the solar radiation, the sun's solar wind, charged particles, radiation. I'm talking about the kind of radiation that causes skin cancer, the UV rays, and all the other charged particles and radiation that comes off of the sun, not just its light and its heat, but all the other energy that is doused down onto the planets all the time. Earth has a shield. We call it the electromagnetic field. Mars lost its shield when its core turned cold. And over time, what was an idyllic, beautiful possibilities on the planet ended up fading into a desert. Some of the water was saved at the North Pole and the South Pole. It froze up before Mars lost its atmosphere. But how Mars looks now, check it out. Looks a lot like Utah, except no atmosphere to speak of. In fact, the air on Mars is about less than 1% as thick as the air you and I are breathing right now. So take a breath. That's one atmosphere worth of pressure going into your lungs and out of your lungs. It presses on us, that pressure. We don't feel it because our bodies are strong enough to resist it. But if you were to step out on Mars without a protective suit, it would be like stepping out into space almost. It's not a pure vacuum, but less than 1% of the air we have now available, in our environment. A person would live less than a minute trying to breathe freely on Mars. Basically, bad things would happen. The loss of pressure, you'd bleed in your lungs, you wouldn't have air to breathe, you'd suffocate. The soft parts of your body the liquids would immediately try to escape what they're being held in. So it's a horrible way to die. For now, we need suits to live on Mars. But let's take a look, a little bit more information about those in chapter 5, I believe. We will get to chapter 5, and we will be able to really explore the possibilities for Mars. So your profiles will look like this. Here's the profile for Earth. This is page 12 and 13, where on the left side, make a beautiful picture. Please trace your circles, my friends. Find yourself a round object to trace, whatever that may be. Trace a good circle. Please do not freehand your circles for planets. Earth is a beautiful sphere, not a potato. You got this. Give it the beauty that nature has earned. And then the facts section at the bottom, your paragraphs about the Earth. Talk about what you know. Talk about your experiences. Talk about life being on the Earth. Okay, that's important to include. The conditions necessary for life: our water, our pressure, our solid land, atmosphere, right? And warmth of the sun being just the right distance away. When you're finished with this page, move on to Mars. Right? A good picture of Mars. Again, trace your circles, make them good. Show some features. Yeah, it looks kind of reddish, brownish reddish. Make the color match reality as best you can with your colored pencils that I issued to everyone in the first weeks of school. Facts, there we go. Got to say, give it some data. But the most interesting part, I feel, is what you put in your paragraphs on page 15. Okay? So add those, make it something you're proud of, do some real looking into facts about Mars using your sources back from page 4. Flip back to page 4 if you need to. There's tons of sources that are available to you on page 4. Excellent way to get started. All right, so that concludes our discussion of the Earth and Mars. A quick look at the pages we've already built. Page 2 and 3, you know about those. Page 6 and 7, the sun and the moon. And there's Mercury, Venus. We talked about today, Earth and Mars. The planets coming up. Well, what's next? The asteroid belt. Be sure and watch that video. It's just been posted as well. And then we'll move on to the second part of chapter 1, where we add the gas giants and the objects beyond their orbits, beginning with Jupiter and Saturn. So finish this one up. When you're done with page 17, be sure and turn it in to me, send me pictures of it, or show it to me in class, and you'll be good to go with your A in astronomy. Thanks for watching. This concludes our lecture today of the Earth and Mars. Keep going and keep looking up.